Alright, you can read Robotic Essentials. If we break basic robots down into 10 essential skills that all robots have, you have some type of thinking system. You need to have a program mindset, which we'll get to here in a minute. You need to have active learning. It's good to have science or some type of applied mathematics. It's not essential, but there is math involved and there is some physics involved, so that's always good. You need to have sound judgment and decision making. You need to be able to write things down. You need to be able to think things through. Possibly hit ideas off of people and go through positives and negatives and be able to know when to call it quits on a certain idea. You need to have good communication with your team. Just saying, just drawing a quick sketch and then saying, here, build it, and then getting upset when it's not exactly what you wanted. Being able to draw, being able to talk about it, instead of saying, here, I'll do it, or you guys just don't understand. It could be the part that you're not communicating well. You need to understand technology designs. That includes schematics. That includes being able to draft. That includes what are the limits that your robot can do. What is the work envelope, etc., etc. Complex problem solving. Complex problem solving is another way of saying multi-step problem. First you do this, then you do this, then you do this. And in between each of thises, you have an individual problem to solve. So complex problem solving is doing one task and solving that problem, then moving on and doing another task and solving that problem. And then persistence. Don't give up. Don't say, this sucks, and push it away or whatever. You may need to take a break. That's fine. Taking a break is not quitting for the period. Taking a break is coming in and getting a drink of water or whatever. But you need to have persistence in order to be able to solve the problem. Whenever you build a robot, you need to ask the following questions. Number one, what is your robot supposed to do? If it's supposed to be able to pick up things, then you need to have a gripper on there or some type of gripper. If it's supposed to go fast, then you need to make sure that the gear ranges are what you need it to do. If it's supposed to go into the middle of a fire, you need to make sure that it's protected. That type of thing. What is the task? And again, this is where the thinking logically comes through. This is also where the complex problem solving comes in. You may need to look at a maze and get to a maze, and then once you get to the other maze, pick stuff up or do whatever. So what is the task? And the task may be many small ones to add up to the big one. What are you allowed to do? What are the rules? This is more for our class stuff or possibly, possibly collegiate stuff. Like if you're competing, what are the rules type of thing? And then what are the limitations? What are the limitations of your motors? What are the limitations of your hardware? Is it better to use steel or is it better to use aluminum? Why do you need it to be lighter? So those are the things that we're thinking about. This is where we're getting into real robotics here. What type of movement do you need? And we'll go into the 6 axes of movement here in a little bit. Fluency of movement. Do you need it to be smooth? If you need it to be super smooth or without a bunch of jerks or, if you need it to be able to do like 2 or 3 movements at the same time, then you're going to go to the better motors. Because the cheaper motors tend to, think of things in degrees. So, and then 6 degrees of freedom, again, we'll talk about here in a minute. And then what is your end effector? Does it need to be a magnet? Does it need to be 2 claws, 3 claws? Like if you're picking up a ball, 2 claws is not real easy to do. Does it need to be 3 claws? Are you picking up something that could break? Do you need to put rubber on the end of it? Does your end effector need to be a welding rod? Does your end effector need to be a cannon? Does your end effector, again, I could go on and on because there's numerous end effectors. This is supposed to be where a video comes in and shows you the 6 degrees of freedom. I'm going to provide a link that will show you this video. So there are a huge number of robot programming language. There's BASIC. Pascal is a really old language. I mean, when I say really old, it was back in the 70s. It was a major language. In BASIC has now kind of morphed into C and C++ and Robot C, which is what we'll be using. Industrial robotics, everybody writes their own. So there's Rapid, KRL2, PDL, all of those. A lot of times people write their own language for their robot. And you can see the other ones down there. Okay? C and C+ would be if it's in a general type of thing. And then most of you know what Python is. When you think about robotic languages, you have to think the programming mindset rather than be proficient in a specific language. I'm going to teach you C++ or C, robotic C. But that doesn't mean that you will know what to do. I will tell you the theory and how to group stuff and how to think. So that when you set up a program in whatever language you have to learn, that you have to have the programming mindset. What can it do? How do you run subroutines? How do you make it repeat itself? That type. All right, here we go. I thought there were 7. I was going from memory. These are all the different types of robots. I got these from the Industrial Engineering and Electrical Engineers Association. You can see the thing down there. But anyway, these are the 15 different types of robots. Aerospace robots, ones that can fly. Guys, we can go everywhere from drones to, like the bird-like things. And now the military has even made like flying insects. So it's crazy what all they can do. Consumer robots, and these are getting more and more sophisticated as time progresses. I don't know if you recognize the ones on the outside. These are pets that are programmed where you have to press a button to feed them or do whatever. But those are like the very simple types of robots. You know what the middle one is? It's a vacuum cleaner. But as time progresses, they are getting more and more individual. On board some Royal Caribbean seas or Royal Caribbean ships, there are robots that make and pour alcoholic drinks. And it wouldn't have to be alcoholic. You could get it to mix any type of drink. But you get what I'm saying. You want to make one that goes, that makes drinks at home, you can do that. That would be a consumer robot. Disaster robots. The 3 pictured here are some type of search and rescue. The middle one is going in underneath like disaster buildings, and then the fire ones obviously, and that's even got water associated with it. So you can have those. They perform a number of different tasks, and these are growing every day. Different people make different disaster robots to do a different project. 3 or 4 of you turned in different types of disaster robots. Some of them look really cool. All right, here we go. Drones. Drones are getting more and more sophisticated. They're getting more and more lighter, and they are used for different things. I will tell you this, that unmanned drones are becoming very problematic around venues because they can also carry payloads like explosives and things like that. They are trying to figure out how to deaden the air in a circumference, in a radius around events without deadening the air inside the event, so like people can use their phones and things like that. But these are really cool. The one on the far right is a what they call a quadcopter drone. And the really cool thing that's about this is the camera that's hanging there. It's on what's called a gimbal, which means that if the wind is blowing around the drone a little bit, the camera is going to remain virtually still. It's quite incredible to see. Educational robots. The one on the left is a VEX robot. The one in the middle is a program called FIRST. FIRST Robotics is where you get the game and basically you have to make your own robot. And then you have Sphero balls over to the right. These are kind of cool. They're Bluetooth controlled, and you guys are going to have a chance to play with these here in a little bit. Entertainment robots. I don't know if you guys even know what the ones on the right are. Those are Chuck E. Cheese robots. They're probably one of the earliest type of entertainment robots. They were called animatronics or something like that. But anyway, sometimes kids were just like deathly afraid of them because they also played in a band. I didn't show the rest of the band, but that was the original Chuck E. Cheese, and they would move around and their mouth would open and close as music played, like theoretically through a microphone, but really it was just music being played. Yeah, you can see the other stuff. Another huge area that is growing by leaps and bounds. Get it? See what I did there? Exoskeleton robots. Really, this area is not only being done by the government, but you have independent contractors as well, trying to replace limbs, trying to enhance limbs. Sometimes the limbs are working, they're just not working as well. And so they try and enhance what's there. And then you have military grade where they're enhancing fully functional bodies, but instead of jumping like 3 or 4 feet, now you can jump like 15 feet. I don't think we're actually there with that kind of thing yet, but this is one of the things that they're working towards. But they can replace legs, they can replace arms, they can replace fully functional hands. And if you were to get on and look at some of this stuff, you can see what all they're doing. It's really, really quite extensive and cool. All right, in my opinion, the creepiest area. The one to the left is called Sophia. You ever really want to get creeped out, look her up on YouTube. It's just weird. The one in the middle is put out by Honda, and it's won a bunch of awards. And then I think the one to the right is another form of Sophia, but I'm not exactly sure. These are being heavily developed. I've told classes in the past that Asians have kind of a thing for these humanoid robots. I mean, I know everybody, not everybody, there's a lot of people that develop them, but the Asians tend to create the most lifelike, which in itself is super creepy. Yeah, look up Sophia and see if you can sleep tonight. Medical robots. They can do so many different things. The one to the right is probably one of the best known as far as that is. It's called Archimedes. And it can have all these different probes and sensors and vacuums and whatever. And it can do, it can do a stitch on a vein as small as like 2 widths of hair. It's just absolutely incredible. It does things that no human doctor could ever do. But he's controlling it with hand things. I don't know where the other 2 pictures came from. I don't remember, but there you go. Oh, excuse me. It's called Da Vinci, not Archimedes. My fault. A source of great controversy are the military and security robots. I mean, military and security robots. So the good side, they can go in and they can defuse bombs, and they can go into an area that is really dangerous. The bad news is, and what's kind of thinking is that should a robot have the ability to be able to pull the trigger? Military and security robots can go as far as, and I'll show you later, there's a 60-minute thing where a swarm of drones find a person that they're looking for, and then one of them has the ability to be able to crash land and blow up near the person. So, this is exactly what we're talking about. Should there be a human on the other side that actually flips the switch? Or should it be the drone identifying the person and going in after it? The one in the middle is a roving drone that is used for security in industrial situations, like Apple or Dell or one of the other major technology companies, or somebody that develops secrets for the military. What those do is they just kind of roam around, and as you pass by them, or as you unintentionally turn a corner and they're there, they look at your face and they try and find your face in the database of faces of people that should be there. And if you're not there, then it alerts security, hey, we've got a problem. It's an interesting little drone. Research robots. These are basically robots, I would say more or less, usually made in I want to say collegiate atmospheres at the university level. That's what the Cheetah is on the right. The one in the middle was a study to see if people would just blindly shake a robot's hand. I started to say a robotic hand, but if the robot came up and introduced itself to you and see if you would shake his hand, and then the one on the left was just a robot that was developed to see if it could walk, and it's got no upper torso. That's it, but it can walk just like it is. Self-driving cars. I don't know if I am ever going to see the day where you get into the back of a car and tell it to go someplace, and there's nobody driving it, and you end up at the other place. I don't know if we will ever get to that point. But I mean, they're becoming a thing. In fact, there was just recently a major lawsuit where somebody from one of the big companies left company A, and he was like one of the major developers, and then he turns around and goes to company B and basically shares all of the secrets. Google has been a huge pioneering area of this, and really Google has been because they were the ones that started such accurate mapping, and so self-driving cars. Telepresence robots. Not a big thing, until like the whole pandemic, and since then, telepresence has gotten kind of huge. And what telepresence is you can be there without being there. Sometime it may have an arm or some type of manipulator. The one on the right carries messages to and fro, and it's really tall because they want people to be able to, quote unquote, look it in the eye. They talk down to it, or they talk stupid if it's really low. So it's all raised up. And telepresence is where I'm here, but I'm also with you. I'm here, but I can also see what you're doing. The very interesting thing that I just found out, actually yesterday, is that if a doctor uses telepresence with you, if he can talk to you, if he can see you, if he can see the weird bump on your elbow, he can actually charge you the same rate as if you were in the office with him. But yet it's all lower cost altogether. So that was just kind of interesting thing that I found out yesterday. And there you go. Underwater robots. Here they are. The one on the left is the one that I know the best. It is one that's being developed to go into parts of Chernobyl, because a part of they pumped so much water into Chernobyl to try and get it to cool down. So the bottom part of Chernobyl is actually underwater. And what they're trying to do is they're trying to send robots in there to cover up the core that's making everything radioactive. And they can get a robot in there, and it may get 15 or 20 minutes of work into it, and it covers up the core a little bit more each time. And then the robot just gets so radioactive that it stops working. That's the reason why I put that picture in there. But there are underwater robots that can do a lot of things. They also used an underwater robot to cap the oil spill in the ocean where the pipe broke off from the oil rig here 4 or 5 years ago. There you go. And then industrial robots. And when I say industrial robots, I'm talking about different types of robotic arms. There's Cartesian, articulated, cylindrical, polar, SCARA, which we're going to talk heavily about. It's going to be on your final exam, and a Delta robot. And you're going to get examples of each of these. Here are the definitions, but when I pulled in the slide, it moved stuff around, so I apologize. Here are the definitions for each of them. I'm not going to go into them. I'll probably remind me when we're in class, and I will give you examples of each of these. And for those of you that are a Star Wars fan, there you go. I hope that this has been a little bit insightful for you to kind of see all the different areas of robotics. If you're going to do, look up some robots. You can get lost at all of the different types of robots. Pick an area and start looking at some robots. I'm telling you, Sophia, weird stuff. Just kind of send chills up your spine to watch her. So have a good time, and we will see you on Thursday or Friday. Bye.